4-8. 4-8 is about identifying real numbers. So there are some categories here that we have to include. Let's start first with your typical whole number. Okay? Your typical whole number would be like number 1, 2, 3. It's a whole number. Okay, so let's start with that category first. Now this category also can fit into an integer. An integer can also be a whole number. Okay, integers could be -1, -2, -3. So those two so whole numbers are a part of the integer. And then these two fall into a bigger category called rational numbers. Rational numbers. Okay, and rational numbers are the combination of those. Okay, it's a real number. It truly exists on a number line. Okay, a number that doesn't truly exist on a number line is known as an irrational number. An irrational number are symbols sometimes used, like pi, okay, and sigma. Those are irrational numbers because you cannot find them on a number line, all right? So if we were to talk about these different types of rational numbers, we have things like this. So to recall that a rational number can be written as a quotient of two integers, such as a fraction, or either as a terminating and repeating decimals. That's okay. Those are still rational numbers. So this is a rational number, 3 4/5. Because written as a decimal, it's 3.8, which is a true rational number. It's real. How about this? We have 2/3. As a decimal, it's 0.6 repeating. That is okay. It's a true rational number. You can even have something as crazy as this. The square root of 1.44. Well, 144 is 12, so it's 1.2, which is a true rational number. Okay, irrational numbers are numbers that wouldn't be a perfect square. So these ones are rational. These ones are okay. Now the ones I'm going to do in red are irrational. Things that are not okay. They're not perfect. Or they don't exist. So irrational numbers can also be written as decimals, but they do not terminate or repeat. They can be written as a quotient of two integers, and they can even be written as square roots. So like this, the square root of 2. Well, that is not a perfect number. There are no numbers that when you multiply together would give you the answer of 2 that are the same numbers. So this is irrational. Okay? How about this one? The square root of 5. Well, square root of 5 is not rational. But it is a real number. It's real, but it's not rational. So for this one here, I would call this one irrational, abbreviating that, and real. Okay? How about something like this? Actually, let me go ahead and go to a new screen here. What if I give you this value, 12.75, negative 12.75? Could you find that on a number line? Sure you could. So it's rational. And is this a true real number? Yes, it is. And it's a real number. Okay, so this one gets both of these categories. All right, what about this number here? What if I did the square root of 16 over 2? Well, what is the square root of 16? It's 4. 4/2. Okay? Well, 2 goes into 4 2 times. So this crazy looking thing, it is a whole number. The answer is a whole number. The answer is also an integer. Okay? The answer is also rational. And the answer is also real. So this one had 4 different categories it followed under. Okay, let's try this one. How about the square root? Oh, for heaven's sakes. How about the square root of 9? Square root of 9 would be 3. All right, how many categories can we get here? Well, it's whole. It's an integer. Even if it's positive, it's an integer. Doesn't always mean integer. Doesn't always mean it's positive, or negative. It's rational. And it's real. This one got all 4. Okay, how about this one? Negative 35.9. Well, it's a number we would find on a number line, so therefore it's rational and it's a real number. You could really owe someone negative $35.9.90. All right. So when you're going through these, you want to make sure you label them correctly. What if you have something like this? 0 over 3. Well, we can't divide by 0, okay? So this would just become 0. And is 0 a normal number? Well, it is. It's only rational, though. Okay, 0 is a little funny. So this one here would only be rational. That's the only category it would fall under. Now let's flip this around. What if I put 3 over 0? Now that's a different situation. This is impossible to do. You can't divide something into 3 groups when you have nothing to divide. That's what this says. So this one here is not even real. This cannot even be real. So it's not even a real number or no solution. Okay? Notice the difference here. 0 on top, it equals 0. 0 on bottom, not even close. Not a real number. Undefined. Okay? Now, I'm going to give you a couple. Let's see how we do. We have the square root of 23. Square root of 23, what do you think? Well, it's not a perfect square, so it's not going to come out to a perfect whole number or an integer. Is it a number you would find on a number line? No, because it doesn't exist. It's not real. So this one is irrational. It is a number that exists, but it's irrational. It's not perfect. Oh, let's see if you took notes. 9 over 0. What would we call this? We would call it undefined. Undefined, no solution, whichever one you want to use. Okay? All right, how about this one? Oh, my pen is just not having a good day. The square root of 64 divided by 81. Well, what is the square root of 64? That's 8. What's the square root of 81? That's 9. Okay? Is this a normal number, a real number? Could you find it on a number line? Yes. So this one is rational. All right. I hope this helps you.